Okay, initializing, that means I'm recording now. What did we talk about? What were some of the properties of the exponential function? Let's say I had f of x equaled a to the x. What are some things that are true about it? Yeah. Okay, domain is all real numbers. What else? What's the range? Kaylee, what's the range? Yep. Y is always greater than 0. So it's positive numbers. What else is true? Yep. Horizontal asymptote at y equals 0. Perfect. Another one? Yep. What has to be greater than 0? Okay. The base has to be greater than 0, and the base cannot equal 1. Okay. What if the base was bigger than 1? Is it an increasing or decreasing function? It's increasing. F of x is increasing, and it looks something like this. What if the base is between 1 and 0? It's decreasing. F of x is decreasing, and it looks something like this. Okay? We talked about all those things yesterday. We graphed some things out, solved it, exponential functions, and we said this number, if you multiply it in front, is a vertical stretch. All right? And this is a vertical shift. This is a shift, and this is a stretch. All right, so we're in great shape. I think it's time to move on. I forgot where we ended up. I think we did an equation, didn't we? We did that one, didn't we? And I believe we did the one where it shifted.
Yeah.
And I think we're ready for this one.
Yep.
Fantastic. So this one, another equation. This is why you have to know what the graphs look like and how the equations work. Because it's easy to say, sketch this graph, and just type it out. But on this one, y-intercept of 6. Do you remember what the point 0, 6 was good for? Oh, there is no vertical shift. So the horizontal asymptote's at y equals 0. Okay? Do you remember what the 0, 6 was for? Does it find A or B? All right, this finds B. So I know my equation is going to be f of x equals 6a dx. Because almost any number to the 0 power is 1. Okay? Almost. What, is 0 to the 0 1? 0 to the 0. Is it 1? It says what? Error! So not every number to the 0 power is 1, but most of them.
That's why I access.
Right. Now, wait a minute. Any number divided by itself is 1, right? Almost any number.
Except for 0.
Well, 0 doesn't work. Yeah, 0 divided by 0 is not going to be 1. All right, 6a dx. Sure, all kinds. Take more math classes, you'll see what they are. What is this number for? 2 and 3/32. Put in 2 for the x, 3/32 into the f of x, and solve for a. Just so the pencil moves all by itself. 3/32 equals 6a squared. All right, Miss Suits, what do you get? Holding on.
Don't you get 1/6 and then you just make this for each document?
Yeah. 1/8. I think that's what I got. Is it plus or minus? Because a squared, it can either be positive or negative. Which one is it?
Positive.
It is. Why is it positive? Right. 6 times 1/8 to the x. When you're working with exponential functions, it's always going to be positive. When you're working with algebraic equations, it could be both. So that's why you always have to check. Is this an increasing or decreasing function? What is it? It's decreasing function, right? Because this number is between 0 and 1. So f of x is a decreasing function. Has a y-intercept at 0, 6 that we talked about. 1, 2, 3, 4, 5, 6. Does something like this. Okay? So there's a decreasing function. By the way, FYI, decreasing exponential functions are known as decay models. Okay? What do you think they're called if they're increasing functions? Growth functions. Okay? So that's the difference between growth and decay. I feel pretty good about that. Oh! Drug is limited through the body. Suppose the initial dose is 10 milligrams. Suppose the amounts. Hey, look at all this. I mean, this is great stuff.
Yeah.
I love these questions. This is like true college questions. Give you a test about 15 of these. Drug is eliminated from the body. Estimate the amount of drug in the body 8 hours after the initial dose. Wait a minute. Is this a growth or decay? It is a decay. Okay? So, it is leaving in a certain instance. This, 10, what does that represent? Well, in the problem, what's it represent? Huh? The initial amount, right? If I were to put this on a graph at time equals 0, the amount in the bloodstream is 10 milligrams, isn't it? 10. That's how much you're starting with. And it goes down like this. Okay? Now, there's a lot of reasons why people take mathematics at Parkland. One is, if they want to increase their pay and they work for a hospital, the more math classes they have, the more things they can mix, like medicines and things like that. They've shown a skill for being able to logically reason and follow directions. So whenever I see this question, it always reminds me of some of those people that pass the classes and get a pay raise. Estimate the amount of body 8 hours after the initial dose. How would you do this one? Right, that is going to equal t. So t is going to equal 8. So in function notation, it's a of 8 equals 10 times 0.8 to the 8th power. This is no more than your ability to punch things down correctly on the calculator. And with that big calculator on your desk, it should be pretty easy to do. Now it's on your desk. Let's see, where did it go? There it is. Oh no! Large screen. 10, parentheses, 0.8, caret 8, enter. 1.677 milligrams, right? That's how much is left in the bloodstream after 8 hours. Milligrams. Sure. 6.8, how's that? 1.68 milligrams. Fantastic. Part B. What percentage of the drug still in the body is eliminated each hour? What percent? Oh! At 0, how much did you start with? 10! 1 hour later. Plug in 1, and what do you get? T! 8. I'm going to change my X and Y right here. I don't think so. 12% eliminated? Could be. Probably. Looks like it. Well, how do you find that? Well, sure. If you put in 2, what do you get? 6.4. How do you find percentage of change. You take the amount of change divided by the original amount.
So if you just put
How much is being eliminated right here? 2. 2 and then over 10, so that gives you what? How much percent? 20%. So 20% is eliminated. Does that sound right?
yeah.
Well, yeah, if your base is 80%, you're keeping 80% of it each hour, aren't you? 80% of the previous amount. The question is asking how much is being, excuse me, eliminated.
Then it goes a little more.
Well, I don't know.
Because it's the same amount because you, even 20% of maybe 1.6 check.
Oh yeah.
0.4.
Yeah, it's always 20% of what's remaining. That's why it's exponential. You have 80% remaining of your original amount, and then 80% of that amount each hour after that. So 20% is eliminated. Or you have 80% left in your bloodstream after each hour. Okay? 2? That's how much it changed. If this is my original amount, how much did it change in 1 hour? Because it's asking for each hour. It went down by 2. Yeah. 1 over T. All right. Compound interest. Do you know all these back there? Good. What's A stand for?
Area.
Nope. The amount. Oh, you know what? In this class, we'll just call it the total amount. It's actually the amount accrued in your account. The total amount in your account. P stands for what? The principal. The original amount you started with in your account. You go to the bank, you put in $100, the principal is $100. What is the, I think it should be principal. Oh. What's the R stand for? Interest rate. Your calculator, in all the places you've been, you have not found a percent key. The only percent key is under the apps finance menu, which we don't go to. So every rate has to be written as a decimal. You have no percent key. N stands for what? Correct. So for instance, if it's compounded annually, N is 1. Compounded semi-annually, N is going to be 2. If it's compounded quarterly, N is going to be 4. Compounded monthly, N is going to be 12. It does. That's when it's compounded continuously. Okay? So that's what N stands for. T in a business model is always in years. Okay? T is always a number of years. If you're talking about 6 months, T is a half. If you're talking about 3 years, T is 3. In scientific models, T can be minutes, seconds, hours, days, months, years. In business model, T is always in years. Okay? Unless you're working with credit cards, that's a whole different industry. Okay? So it's going to be either 1, 2, 4, quarterly, monthly. Oh, I believe in this book it changes, but I think daily is 360. I think that's daily is 360. Okay? It changes from book to book. This is compounded monthly. Everybody knows that. Quarterly. Semi-annually. And annually. Okay? So, we got the equation. We're in great shape. Let's start using the equation, shall we? If a savings fund pays interest rate at 6% per year, compounded semi-annually. How much money invested now will amount to $500 after 1 year. I think I have all the players identified in this equation. $5,000. That's how much I need to invest now. No,
Oh, yeah, that's who wants to be.
that's what you want to be at the end, so that's A. T is equal to what? 1 year. What is this? 6%. The rate, 0.06. Some people always mess that up. They put 0.6. Semi-annually means what? N will equal 2. 5,000 is A. You have to solve for the principal, which is P. Okay? So we have all of our players identified. 5,000 equals P1 plus 0.06 divided by 2, 2 times 1. Once you set it up now, it's a matter of you just being able to punch out the right buttons on the calculator. Since we've used the calculator quite a bit, I'm going to do it this way. I'm going to take parentheses 1 plus 0.06 divided by 2. Close that off. Raised to the 2 times 1 power. Why don't you just put 2? I want to stress the fact that this needs to have its own parentheses when you have 2 numbers there. We're talking about money, right? So 2 decimal places. So I'll be enter. And what do I do with that number to solve the equation? Take 5,000 divided by it, and don't round too much. Second answer. There, I didn't round at all. I got $4,712.98. People do this all the time. $12.98. Some people are two times 1, correct. You can. I said I just want to stress the fact you have 2 numbers up there. You have to put parentheses around the exponent. Some people do this all the time once they start reaching about the age of 40, 50. They try to figure out how much money they need to retire, so they have to start investing now. Some people start at the age of 12. If their parents are financial advisors, they already have accounts for retirement starting at very young ages. Okay? Moving on. A certain department store requires its credit card customers to pay interest on unpaid bills at the rate of 18%, compounded monthly. People are so excited to get their first credit card. I was excited. I got mine when I was 30. Oh, that was great. A certain department requires if a customer buys a television set for $500 on credit and makes no payments for 1 year, how much is owed at the end of 1 year? So why don't you pick up your pencil, give this one a go, I'll walk around, see what you come up with. Once you identify everything, it's easy to punch down the calculator. So give it a shot. Correct. All right, now you set it up? Good. And you just punched out, right? All right, let me give it a go. 500. 1 plus 0.18 divided by 12 caret 12 times 1. Did I get that? $597.81. That's how much you owe now for the television. So the television once cost you $500. Now it costs you $597.81. Einstein said the most powerful force in nature is compound interest. Interesting. That's what he said. I think he's being a little tongue-in-cheek. Yep. I don't know, maybe. I'll get this done first, though. This has priority. Oh, we are done! Excellent! Sure.
Wait, no, I'm great.
Well, I got that.
I know, but I don't know.
You can read. We got a 5 for 10. Oh, we got plenty of time. 10, 20 minutes. Yeah.
We're 47, by the way.
All right. So, homework check. On what page?
We're homework check?
Yeah. 288. And, oh, there's homework. How far, how far did we get? On this section, we got to go to 47? Okay. All right. I think it was 29 to 47. Okay. All right, let's take a look at 6-1 and see what we got. Or 4-1. These are going to be easy. This is an opening chapter. Easy points.
We're doing 5 or 10?
Probably just 5. Oh yeah, I still am recording. Page 288. Oh heck, I'll record this. What the heck? Whoever listens can do it and turn it in. Number 5. Well, we did. So what?
We went to like 51.
51. Oh, we can do 7s then. Can't we? Multiples of 7.
Let me double check.
7. Oh yeah, 14. Easy. 21. Piece of cake. Yeah. 7, 14, 21, 28. Oh yeah, easy. 28 and yeah, 35. That's pretty easy. 5 or 10. All right, good. Close this up. That was a quick lesson today. Oh, we're doing homework check.
We did a lot.
Good.